1.4, we go into equations and also inequalities. So the first goal is just checking and solving equations. You can pause and read through this if you'd like to. We're going to go ahead and put it into action. So the first thing we're going to do is to check to see if the numbers 2 and 3 are solutions of the equation 3x plus 1 equals 7. The way that we do that is to substitute each of them in to see if it is a true statement. So I will do 3, whoops, need to get my pen here, sorry about that. So we have 3, and then we're going to substitute in 2 first, plus 1, and we want to know if that's a solution, it will equal up to 7. And I'll go ahead and I'll write the other one. 3 times 3 is what we're going to substitute in this time, plus 1, is that going to be a true solution? So 3 times 2 is 6. 6 plus 1 does equal 7, so this one is a true solution. 2 is a solution. And then if we do the next one, 9 plus 1, does that equal 7? It does not equal 7. Remember, you can use the symbol of just crossing out with one diagonal usually, and that says that 9 plus 1 does not equal 7. So 2 is a solution, 3 is not a solution. Moving on, tell whether the numbers 2, 3, and 4 are solutions of the equation. Same thing, we have a little bit more complex equation here, and we have 3 numbers to check. So we'll go ahead and do the same process, substituting in. So we have, I'm substituting 2 first. Does that equal 10? Next, I will substitute in the 3. I'm just writing all my equations first, and then I'll go ahead and solve those. And then I can go ahead and substitute in the 4 for my x value. All right, so 4 times 2 is 8. 8 minus 2 does not equal 10, so 2 is not a solution. 4 times 3 is 12. 12 minus 2 does equal 10, so 3 is a solution. And 4 times 4 is 16. 16 minus 2 does not equal 10. So the only solution out of those possible numbers that we checked would be 3. And remember, you can use that just to say it's not a solution. You can use the equal sign with the diagonal through it. That means it's not equal. So we can also use mental math, and this is one we use quite often, I can tell you as an adult, to solve real life equations. We need to buy some ingredients for nachos. In the supermarket, you find the bag of tortilla chips, you find the beans, the cheese, and the tomatoes and the olives. But you only ran into the grocery store with a $10 bill. So about how much more money do you need? You want to know if you have enough before you go and try to buy all of these ingredients. So we can simply, I know you can grab your cell phones, but that's not what it's asking you to do right now. So we're going to just estimate instead. So if the tortilla chips cost $3, we're going to say instead of $2.99, and we're going to say that the beans cost $1, and we're going to say that the cheese costs about $4, and the 2 tomatoes cost $1 total, it says. And then the olives cost $1.50. Now you could do this as 1.5 if you want to get close. Otherwise, if you want to make sure you have enough money, you could overestimate and do that as $2 just to make sure you have enough. We're not considering tax right now. We're just looking to see how much money that we will need. So if you do the 3 plus 1 plus 4 plus 1 plus 1.5, you're going to end up with 10.5 as your total. And that does not equal the $10 bill. You're going to need at least 50 cents more just for the ingredients. And if you figure tax, you're going to need a little bit more than that. So estimating that. And if we do that, we can look at the solution that they have in the book is the total cost equals 10 plus what number of dollars, and it's going to be 50 cents. So we would need 50 cents more for the ingredients. Now, goal 2 is checking solutions again, but this time we're dealing with inequalities. That means we're talking about less thans and greater thans. Remember your symbols here. We have the less than, we have the less than or equal to. It has the equal sign with it. Greater than and greater than are equal to. So this time the number has to follow the requirements by the inequality symbol. It is essentially the same process. Here we have a veterinarian, and your vet told you to restrict your cat's caloric intake to no more than 500 calories each day. So no more means that it has to be less than or equal to, whoops, on the wrong tool here, less than or equal to 500. We can't make it go above 500 calories. So let's go ahead and see if we give the cat 170 calories at each one of its feedings. So we'll do 3 times a day, 170. And we want to know, is that going to be less than or equal to 500 calories? And we can also do 3 feedings a day of 165 calories and see if that's going to be less than or equal to the 500 our vet told us to stick to. So the 3 times the 170 comes up to 510. That is not less than or equal to. Same symbol, just crossing that out. If you feel like that's hard to read, you can also do an X over the top of it because of the symbols. It just depends on how clear you write. And then the 3 times the 165, if I limit each one of those feedings to 165, just 5 calories less a feeding, I'll end up with 495, which is staying in my less than or equal to 500 calorie limit that the vet asked me to stay to. So I have to have each feeding cannot be more than 165 calories. So the same process, substituting it in, and just make sure that it works for the inequality symbol. And that finishes off that lesson.